Hey everybody, so today we're going to take a look at two things that you've actually done separately before, which is just solving equations, first degree equations, so just no exponents, and also working with inverse trig. Basically the way this works is you just start by solving an equation, such as this first one here, 2 sine theta minus 1 equals 0. We'll add 1 to both sides, and we'll just keep working to get the sine of theta by itself. Alright, so we'll divide by 2, and you end up with the sine of theta is equal to 1/2. Now this is where our work with inverse trig comes from. We know if we want to find out what angle theta is, we have to take the inverse sine of 1/2. Now some of these will be unit circle friendly, such as 1/2, rad 2 over 2, rad 3 over 2, and they're negatives. And some of them won't be, where you'll have to use the calculator. But if you choose to use the calculator, after you take the sine of 1/2, you're going to end up with 30 degrees. Now the thing is, we know that there's a possibility of up to 2 possible angle measures that will get you a sine that's 1/2. So what we have to do is we have to take a look at our quadrants and figure out which other quadrant sine would get us a positive 1/2 in, which for a sine would be the second quadrant, and we'll draw our 30-degree reference angle in here. So it's bringing back some of that older material. Now, in order to figure out what that angle measure is, we need to figure out how far it is from 0 all the way around to that terminal side of that reference angle. Or in this case, it's going to be 180 minus our 30 degrees. In other words, getting 150 degrees as our second angle. So from here, we're just going to write theta as our answer of two different angle measures. We got 30 degrees and 150 degrees as our two possible angle measures, where when we take the sine of that, we'll get 1/2. To take a look at our second example, we have 2 cosine theta plus radical 2 is equal to 0. So we're going to do the same thing, solve for cosine theta. Subtract the rad 2's over, so you end up with 2 cosine theta is equal to negative rad 2. So you got a negative now, so keep an eye on that. Divide by the 2, and you get cosine theta is equal to negative rad 2 over 2. So here's where we'll do a little inverse trig again. So you do the second cosine button on your calculator, or use the unit circle if you'd like, of negative rad 2 over 2. So theta equals the inverse cosine of negative rad 2 over 2. And if you use your calculator, or if you use the unit circle, you should end up with theta is equal to 135 degrees. Right, so that's going to be the first angle you get, 135 degrees falling in the second quadrant. Now the problem is we need that second angle. So again, look for that reference angle, right, bringing back that reference angle from earlier this year. And we're going to have to draw that reference angle in another quadrant where cosine's negative. So looking at our ASTC, cosine's also negative in the third quadrant where only tangent's positive. So we put that 45-degree reference angle in that third quadrant, and you're going to draw the angle over and take your 180 degrees to get there and add the 45 to get to our final angle with a final answer, a final angle of 225 degrees. So you have two final answers here, 135 degrees and 225 degrees, both of them being your answer. Now, if you do get angles that don't work out so nicely in terms of the unit circle like this, where you get straight answers and you have lots of decimals, in most cases you're going to have round to the nearest degree, but keep an eye on what the question's asking for in terms of where to round.